Here is a question from JEST 2012 which was also asked in JEST 2014. So this is a repeated question, and the question is from Special Theory of Relativity, particularly from the topic Lorentz transformation. First of all, let us recall what Lorentz transformation is, and then we will solve this problem. So if we have a frame S, this is S frame. In S frame there is an event A, and its position in S frame is given by x, y, z, and its time is given by t. Now the same event, when measured from S prime frame is moving with velocity v in the x-axis direction, in the positive x-axis direction, and from the S prime frame the event A, position of it is given by x prime, y prime, z prime, and time is given by t prime. Now Lorentz transformation relates x prime with x. X prime is equal to x minus vt times gamma, y prime is equal to y, z prime is equal to z, t prime is equal to t minus vx divided by c square times gamma. Now these relations, which relate the measurements from two inertial frame of references for the same event, these relations are called Lorentz transformation equations. Now suppose there are two events like in this problem, then what we do is we will apply Lorentz transformation for the event 1, we will apply the Lorentz transformation for event 2, then we will subtract the Lorentz transformation equation for event 1 from the event 2, then we will get the separation. Delta x prime is equal to delta x minus v into delta t times gamma. Delta t prime is equal to delta t minus v into delta x upon c square times gamma, and delta y prime is equal to delta y, delta z prime is equal to delta z. So this is how we write the separation in the events. In our problem, delta x is given to be equal to, the separation of events is 5 km apart, and separation in time is 5 microseconds. So delta x is equal to 5 km, 5 into 10 raised to 3 meter, and time separation is delta t is equal to 5 microseconds, which is 5 into 10 raised to minus 6 seconds. Delta t prime is equal to 0 because the events are simultaneous. Events are simultaneous for an observer moving at speed v. Therefore delta t prime is 0. Therefore if we use this relation 2, then we will get 0 is equal to delta t minus v into delta x upon c square times gamma. Here gamma is equal to 1 divided by root of 1 minus v square upon c square. So from here we can write delta t is equal to v into delta x upon c square. We need v, so we will solve for v. V is equal to delta t times c square divided by delta x. This is equal to delta t is 5 into 10 raised to minus 6 seconds, and delta x is 5 into 10 raised to 3 meters, and we have c square here. I will write one c as 3 into 10 raised to 8 meter per second and another c as it is, because in options we need the value in terms of c. So I will keep one c as it is. So this is equal to 5 gets cancelled, 10 raised to minus 9 times 10 raised to 8 times 3, and then we have a second per meter and meter per second, and at c here this is equal to 3 into 10 raised to minus 1 c, which is equal to 0.3 c. Therefore the speed with which the observer is moving is 0.3 c.